Now we're going to start getting a little more Cisco-centric here. We're going to talk about the Cisco IOS Zone-Based Firewall, or ZBF. And from the name, you can tell that we're obviously going to use zones, right? But why are we going to do that? Well, zones are logical groups of interfaces. Not entire routers necessarily, not entire devices, but interfaces. Now, an interface can belong to only one zone. And we have a couple of important defaults here. Interfaces that belong to the same zone are permitted to send each other traffic. Interfaces that belong to different zones by default are not permitted to exchange traffic. So we've got our old friends Bob and Dan here in zone 1 and a server in zone 2. By default, Bob and Dan would be able to communicate with no problem whatsoever. But they would not be able to communicate with the server, which sounds like something we probably want to fix or resolve, and we're going to talk about that in this video. Now, there's also something called a self zone. It sounds kind of zen. What it does, the self zone covers traffic that is destined for an IP address that actually exists on the router itself. That's called entering the self zone. And traffic that is generated by the router, that is termed exiting the self zone. Traffic that's exiting the self zone. By default, this traffic is permitted. So again, the self zone, it's traffic destined for an IP address used by the router itself and traffic generated by the router, and this traffic by default is permitted. Now, we're going to likely want to change the default behavior between those two zones that we looked at earlier, and we're going to do that with something called a zone pair. And this sounds like something mysterious and complex, right? Well, if you haven't seen it yet, believe me, it's not mysterious and it's not complex, but it's one of two terms in this section that you just go, oh man, that really sounds difficult. It's not really difficult at all, just a couple of concepts we have to remember. We know now that traffic leaving one zone and destined for another is not going to be allowed by default. To allow or inspect that kind of traffic, and allowing and inspecting are two different things, we're going to write a zone pair. All a zone pair is a unidirectional set of rules. And it identifies the behaviors to be carried out against that traffic. You know, do we want to allow it? Do we want to inspect it? Do we want to deny this particular kind of traffic? That kind of thing. Now, you're going to have a zone pair, but it's only going to point one way. Notice that I've got an arrow here from Bob to this server, excuse me, saying allowable via zone pair, but it's a one-way deal. There's only one arrowhead. I'm going to mention this a couple of times in just a few minutes. Zone pairs are unidirectional. With this particular setup, if we wanted Bob to be able to initiate traffic destined for that server and vice versa, we would need two zone pairs because they're unidirectional. That's the toughest thing about zone pairs. Once you remember that and you look at the syntax, you write a couple of them, it's going to become second nature to you. Now, permitting and inspecting, as I mentioned, they are not the same thing. Two options for interzone traffic are permit and inspect. And while they'll both result in traffic, in this case getting from Bob to the server, they will not have the same overall effect. Now, if we use permit, the traffic would get to the server. Bob would be able to send traffic to the server. But with permit, there's no entry made in that state table we talked about earlier. Remember the established connections? We talked about the importance of that. Well, if we're just permitting traffic to go from Bob to the server, that does not make an entry in the state table. And if the server tries to respond with some data, the firewall in the middle of all this is going to say, no, we're not going to let that through because it's not keeping up with the state of the connections. To get that, you need inspect. The traffic would get to the server and the firewall that we have in the middle here, an entry would be made in the state table, and the server could then reply to Bob even if there's no specific zone pair that allows it. So that's a good deal right there. Now, if you're working with a smaller network, there's nothing wrong with simply using an inside zone and an outside zone and just leaving it at that. But larger networks with e-commerce servers and email servers, they may lead you to configure what we call a DMZ as part of your firewall strategy. Let's talk about what that DMZ is. It actually derives its name from the term demilitarized zone, and that's a boundary between military bodies or alliances where fighting is not permitted. It's not a term you hear terribly often today, but we're not going to hear this term DMZ referred to as a demilitarized zone, but you will hear it called a perimeter network on occasion. You'll see why in just a moment. From an IT standpoint, the DMZ is actually the part of the network that is most exposed to outside networks. And here's a list of devices. It's very common to find these in a DMZ. An FTP server, an email server, e-commerce servers, DNS servers, and web servers. And it's not unheard of to have a proxy server in the DMZ as well. Now let's look at this topology. We've got one iOS firewall here. We've got an inside network, got our outside network going out to the internet, and we have a DMZ with an FTP server, an e-commerce server, and a web server. Love the little bag of money there next to the e-commerce server. Now it's easy to look at this and say, well, you know, the only thing we really have to worry about are attacks from the outside. But that's simply not true. We do have to guard against threats from the inside of our network as well. It's just the way of the world. It's just the way it is today. You can also see, too, why this would be called a perimeter network. It's kind of out on the perimeter of everything, near the outside. So we do have to be concerned with those attacks from the inside. So we can take a single firewall or a dual firewall approach. And dual firewall just sounds better, doesn't it? Let's see if it's actually better. Now, the single firewall is also occasionally referred to as a three-legged firewall. Now, how can a single firewall have three legs? Well, actually, this one does. 1, 2, 3. You don't think of them as legs when you're really looking at the drawing the first time, but the inside network, the DMZ, and the entrance to the outside are all connected to this one firewall. So that's a single firewall setup, and here's a dual firewall approach. And do note the four arrows here. Usually for a firewall, a non-iOS based firewall, you would just see all bricks here. You've probably seen that before. If not, I'll make sure I show you one in the next video. But when you see the arrows on it like you would see on a router, that's actually an iOS based firewall. So here's a dual firewall approach, and you can see that that's actually even better. So let's take a look. Let's take one more look at that. So anyway, if we are going from an attack from the outside to the inside, from the inside to the outside, but mostly it's going to be, of course, outside to inside, they've got to go through two firewalls to get to you. So that's a bit more of that layered approach that we talked about earlier in the course. Now, how are we going to apply all this to begin with? We're going to do it with something called the Cisco Common Classification Policy Language, C3PL. I must be kidding, right? Now you got to learn a new language. No, you do not have to learn a new language. Don't sweat it. As soon as we hear the two scariest words, I think, in our business when you're learning something new, database and this, language. Language is the scariest. Like, oh, great, it's going to be all this arcane stuff, and, you know, it's going to be like BGP special characters and formulas and etc. All it's going to be is class maps, policy maps, and service policies. And if you haven't seen class maps or policy maps before, the logic is going to be very, very familiar to you by this point. You will see on the next video. So I'll see you there.